Greetings. Welcome back to the Garden Dojo. Today we're going to be talking about physics and karate. And fortunately, we have a guest speaker, demonstrator, Professor Joe Johnston, who is a 6th-degree black belt in Goshin Jitsu, and you work at the
Mercyhurst University. In the physics
Mercyhurst University. Why is physics important? Well, we need to understand physics because we need to understand how we deliver the power of our techniques. Kinetic energy, force, and Professor Joe Johnston is going to discuss and tell us more about that. The floor is yours.
Oh, thank you. I appreciate the invitation, and I'm glad to be part of it.
We're excited.
Two things I really love talking about are physics and martial arts. So this is a little bit of both. So that's outstanding. But really the study of everything that exists, everything in the entire universe. If it exists in this universe, it's physics. And martial arts is no different. We're just trying to take advantage of the rules of physics to implement as much force and impetus to move and power, as you said, into the opponent, into the target, whatever it might be. So you mentioned kinetic energy. Kinetic energy is equals 1/2 your mass times the velocity squared. So if I want to give energy to my fist has a certain amount of mass. If I want to maximize the potential energy, I got to move it fast. So we want to practice getting a high velocity. Also, the momentum that you put onto something is the mass times its velocity, just not squared, just mass times velocity. But the force to change that is maximized in a minimal amount of time. So something we were talking about a little bit ago, we snap our techniques, or we snap through the technique so that there's a minimal amount of time of contact to maximize the force input on the
So a focus punch, for instance. Now, when we're talking about the mass, we're not just talking just the mass of the hands. We're talking about the whole mass of the body, because you need to incorporate the whole body in order to get the velocity. We need to push off the ground. Okay, we need to push off the ground in order to get that. Now, the idea is to relax the body, so when I do punch, I'm not here. I want to maximize the speed by pulling back. I'm not pulling back, I'm just snapping back. But in order to do that, I need to relax my muscles, because if I tighten up my muscles, it's going to go slow. So I need to relax and come back. It's that whipping action, just like that towel, the wet towel.
yes, exactly.
That's
exactly right.
So you minimize time of contact, and you're maximizing the change of momentum of your own fist. So because you're not just coming to a stop, you're coming to a stop, and that little snap back is a negative velocity. So you're doubling that change in momentum. So it's it all fits in that. That pushing off the ground is Newton's third law. I'm pushing backwards in order for the ground to push me forward. So I'm not hitting them with just my hand, I'm hitting with the planet. I'm connected to the planet Earth. And all of that is going into that.
Which is, we see a lot in boxing, right? They're throwing their jabs and they're pushing off that back leg. Well, we should be doing that in karate also. Matsubu Choki Sensei said, utilize practical application of your martial arts, not the fancy stuff. It's pretty, but it's pretty useless. Utilize your body. We're not looking for pretty, we're looking for effectiveness. Okay, so, and I think that we will bring that in, mass times acceleration. I say effective force.
We say net force in physics class, but it's the same thing. It boils down to the same thing. The force that is input onto the target. External forces cause changes to their momentum, and that's an acceleration. Objects that are sitting still don't want to move. If I want to make that thing move, I've got to apply an effective outside force.
Correct, because if it's, even though it's standing still, it still has potential energy.
Yes.
We're going to be that potential energy. If he's standing still and I'm going to strike, I'm going to make him move, because if I just do this, he's not going to move. But if I apply my mass, accelerate that, he's going to move.
Something we didn't talk about before, but you put it in my mind there. They seek their lowest objects that have mass, want to seek the lowest potential energy they can get to. So they actually want to get to the ground. And we're facilitating. Gravity's on our side here. We're facilitating that ability. And if we move their center so it's not above their base, as you just did, there's a torque, kaboom, they go to the low potential, they fall on the ground. So.
Correct. And we were talking about earlier, but you weren't here for the class. We were talking about punching down as opposed to punching across. If I punch across, tighten up. Yep. Now he's getting a front stance. If I just punch, he's going to take that. But if I punch down, it's going to move him because I'm moving him and I'm striking the vital point. Using the professor's word, it's going to facilitate the gravitational pull. Okay.
To help him achieve the lowest possible potential energy.
Absolutely. All right, so it's important that we learn physics. See, it's martial science. It is martial arts, but here in Kaizen Kan Goju Karate Jitsu, we talk about the martial science. We need to understand how the body works, how the person responds. The response is always there. No matter what this person is doing, you're going to always elicit a response. So the whole purpose is to not just elicit the response, but make them respond a certain way you want them to respond. If I want him to go down, I'm going to punch down, not punch across. Okay. Same thing with physics, right? We're taking the arm. We'll use Toide here. This arm's got to rotate, it animates. It goes up, it bends. If I take that and bend it the opposite way, it's going to go. If I overbend, he's going to go, right? This is a natural bend, but it can only go but so far. But if I take that beyond, it's going to go. It's physics.
It is.
Right?
It's all leverage. I like to think of the art is the creative application of the science.
Correct.
So how do we creatively use these rules to our advantage? And that's where the art,
Yes,
I think.
yes.
But,
And I said, well, you have to learn the science in order to make it artful.
right?
Okay? And in order to make it artful, you have to understand the science. Okay, so they both actually correlate. Right? But we say karate jitsu as opposed to karate do. Karate do is strictly art without the science. Karate jitsu is with the science. That's what we call it, the Academy of Martial Science. We learn the anatomy, we learn the physics, we learn the mobility. You have to, because without that, you don't have martial science.
Those aikijitsu moves that you were doing were just manipulation of levers, right? So kotegesh is just, there's a lever, a force applied at a distance from a hinge. The longer the distance, the larger the torque. So I apply a torque, it produces a rotation. I provide a torque, a distance from a pivot point. It provides a rotation. So all of that is just manipulation of smaller progressive levers. So outstanding.
And here we manipulate those levers to make them even smaller. Okay? Because making them smaller, we call it small circle jujitsu, Professor Wally J, right? Count and watch the response. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2. Okay? Because now I'm torquing this way, and that way. So there's 3 torques on that axis point.
Yes.
As opposed to 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2. Right? So there's a pull, push, torque. Physics.
Yes.
Okay? I'm spinning on its axis. Same thing if I here, right? 1, 2, 3, 4. But if I'm here, 1, 2, 3. If I'm here, 1, 2. I take the slack out. Physics.
The small circle, smaller radius means that since we're dividing by radius in our equation, it happens faster, right? It takes less motion to get the same distance of rotation.
And we get that in centrifugal force?
Yep, centripetal, yep.
So explain that to us.
So anytime anything goes in a circle, it requires a force to make it go in a circle. It wants to go in a straight line. So that force is called a centripetal force. It means center seeking, literally, if you translate it. It means it's pointed towards the middle. So if I want to make Rob rotate, I've got to apply a force towards me to make it rotate. But it's mv squared over r, we're dividing by r. As r gets smaller, the force gets bigger, right? And the velocity goes up. Yeah, and it's velocity squared too. So the top half of them gets the message to come in. Maybe the bottom half doesn't. It has to cover much larger radius in order to keep up. And thus the throw.
And we're using Rob as Bob today.
Thank you, Rob.
But, and using that same concept, if I'm controlling the arm, I'm bringing it to my center. And then
Yes, yes.
same concept, different technique. But the concept, the philosophy, the principles always remain the same. I'm pulling them into me. So if you count that 1 without the 2, I don't need to complete the 2 because I'm pulling them in. This whole mass is coming towards me. And then I'm turning him as I turn myself, pivoting on my toes. Okay? So physics is great in martial arts. And let me tell you, I am not a physics person, but I am a physics martial artist.
Yes.
Martial science. So tell us some more about the centrifugal force and the way, well, as we saw, Rob spun away.
He wants to continue in a straight line. So I'm applying a force to make him turn. If I stop applying the force, he doesn't go out that way. He's going to keep going in the direction that I've got him going. So what you did, which was really cool, as you're spinning this around, so you bring him around. Now he wants to go out, but you kept this tight so that the bottom half went out, but this couldn't. So we kept the radius of the arm small, and it put him into a really vulnerable position.
And you control your opponent
Yes.
by keeping it small.
Yep.
Right, you know, and the whole idea is to keep them close. Love them dearly. Right? And then you can turn around and go the opposite force. Bring that to us. We're really getting into
Yeah, this is great. I love it. So his angular momentum makes him want to keep going around.
What do you call that? The angular velocity?
Angular momentum is angular velocity times his moment of inertia, which is another entirely cool concept. Moment of inertia has to do with how easy it is to turn you. If your arms are in, it's fairly easy to make you rotate. If your arms are out, it's harder to make you rotate. This is why when you're like balance beam, you put your arms out. It's harder to rotate about my pivot point, which is my feet, because my arms are out, my moment of inertia is larger. It's why you carry a big pole if you're a tightrope walker. Okay. So if I make you come in, it's easier to rotate you. So like we're in here, I want to make you rotate. I'm going to keep these in. I don't want, if your arms are out, maybe it's a little harder to make you rotate. I'm going to do something different. So keeping it in nice and tight keeps that moment of inertia nice and low.
Okay.
So it's the symbol I in the equation. It's I times omega, where omega is your rotation.
Right.
So if I can decrease the moment of inertia, I can increase my omega, because angular momentum stays the same.
When I'm pulling them in and turning them, his legs are going further out.
Yep. So his I value gets bigger because you're making him rotate around, right? So, exactly. Yep. It has to do with where your mass is located. The farther from the pivot, the more moment of inertia you have.
Right.
So,
okay, so if you're outside of the circle, that explains tornadoes.
Yeah.
So that's why it's more dangerous out here.
It gets pushed out, right, by its
Even
natural
though it's
rotation.
trying to pull in.
Yep.
And it's being pulled in by the force.
Yep.
And the
centripetal force is pointing in, but its inertia holds it out.
Gravitational pull.
Yep.
Okay, so
The gravity pulls it down. The centripetal force of the wind pulls it in, and its inertia keeps it on the outside. So there's this equilibrium.
Right, okay.
I haven't studied meteorology, but it's all physics as well.
Now, if I was to sever that line, he's just going to go.
Just goes. So
the direction that he was severed in.
Yes. Yep. A lot of Aikido moves will do that, where you come in and then you extend them out.
Right.
So you start the circle and then you make it a line.
Right. So first bring them in, then go.
Yes.
So if I was to bring him in, then go.
There he goes.
Exactly where he's going.
We say tangent to the circle. If you're going in the circle, it just continues in a straight line
Off of that circle.
Yep.
Right. Yeah. Cool. So this is great because you know what? We don't study enough physics. We don't study enough science in our martial arts. We tend to forget and think that it's all about punching and blocking and kicking. It's a lot more than that. The deeper we dive into this rabbit hole, the more we find. There's going to be certain response from the opponent that we want to first elicit, second take advantage of. There's certain response from ourselves in the confrontation that we want to decrease pressure, stress, and be able to respond to the attack. So if Rob is coming in at me, and I'm here, I want to be able to turn this into physical force. Okay? I don't want to just block. I'm still going to get hit, but I want him to think about it, right? So when he comes in, I want him to think about that. And then right there, I'm going to come in. As I'm coming in, physics, leverage. Okay? And then I'm going to pull that circle down.
I saw so much good stuff there. So, I don't even know where to start. So when you had him locked up, it raised his center a little bit, which
correct.
increases the distance between him and the pivot point, which increases the torque on his body that makes him want to fall. And then on top of that, when you lever him down, you're putting that center of mass outside of his base of support. So he's
tilting.
yeah, and if straight line from the center of mass.
Pisa tower?
Yeah.
Yes.
And gravity pulls on your center of mass, and it pulls straight down. If that center of mass is not above a base of support, there's a torque, and it makes you fall.
Gravitational.
Gravitational pull pulls you right down.
Right. So it goes to show that even if you don't understand physics, we should touch on physics. What we're touching on is basically the basics of physics in martial arts, right? So if Rob is coming in and he's coming to strike, the minute I block, I want to send his arm up. Because by sending his arm up, I separate his lat. And separating his lat weakens his arm. And now I can take advantage of that and torque. Notice what I did is rotate.
Yes.
Rotational pull. Coming down. Now all I have to do is apply my gravitational success.
And the lever, you're using his arm like a lever. Yep.
This is coming up, this is going down. We use that push-pull method. I can lock in there and I can sit here all day.
You're actually using two torques. There's a torque from this force and a torque from that force about that pivot point.
That's correct.
Both torquing the same way.
Correct. Which is going in an unconventional way.
Yes.
Right? Tapping him, I want to extend him beyond his balance point. So by doing that, I take him off his center and immediately drop him down. I don't have to hit him. I just have to come in and control.
I did notice as you're coming in, you're talking about not standing and receiving, but meeting the technique. Your inertia, you're using that to your advantage. You are a mass, and an object in motion will tend to stay in motion. Whereas if you're stationary, their force is going to make you accelerate. I don't want that, right? I want to have control of my own center, so I'm going to be the object in motion and meet their force with force.
So if the person is coming in at me, I don't want to be there. Because if I'm there, I'm going to get hit. I'm going to be eating something. So, and also, I want to use both hands to block a single technique. There's no pride in survival. There is survival. As soon as it comes in, both hands. Because now, look at my hands. I can push, pull. I got control of his levers. I can come back. I can go forward. I can go up and down. I can kick, or I can knee, or I can hit the spleen meridian to the back, or the bladder meridian, okay? Or I can just rock his leg and push and control, right? But first thing is, don't be there.
Right? He is an object in motion. He will tend to stay in motion. It takes time and force for him to stop moving forward. That gives us time and allows us to use that force against them as we do a counter. So absolutely.
I love this.
So do I.
That's why I invited Professor Joe Johnston here, because he's a physics master, okay? As well as a Gojin Jitsu master. So We need to get together and study and train with other people who have more knowledge than we do. Don't think that just because you have a black belt or that you're 6th, 7th, 8th, 9th, 10th dan, that you know it all. We don't, okay? So as we get together, we learn and we exchange. That's how they used to do it back in the days with Master Chojan Yagi. There's no such thing as styles are cut out. It was just cut out there. They all got together and they studied, okay? This is the objective of spreading the new.
We were kicking the idea around, actually, of publishing a text with both physics and biology, the anatomy and physiology, as you've been teaching me. So keep an eye out. We might have that published. It's in the works. Anyway, physics, but on the topic you were just saying, I am truly appreciative of your time and allowing me to come and train with you and sharing knowledge.
Because we in fact, we were at one of your students' place not long ago, a couple of months ago, actually. And we exchanged ideas. And that benefits us all because we get to learn from each other. We don't know it all. Not one style is superior to any other style. Every style has its pros and cons.
Yep. Small minds, closed minds are small minds. Right. If you lack confidence enough to learn from other people, then you'll be stagnant and you won't grow.
Even as a professional, no doubt you got to go continue edge. Always learn the sub-arts. There's always sub-arts. And one of those sub-arts, believe it or not, one of those sub-science is physics.
Yes, that is a great kind of overview. So if anybody does have questions or ideas or thoughts, feel free. My email is jjohnson@mercier.edu. And
we'll have that posted here so that you can get in touch with them if you want to.
Yeah, I'm sure I'll leave and 30 ideas will come to me. But I think we covered a lot of basic physics concepts as they apply to martial arts. So.
Absolutely. And again, karate is a broad span. Martial science and martial arts is large, it's huge. And do not get suckered in by just one style. Do not get suckered in by just what your sensei says. Do the research. Check for yourself. Don't be satisfied until you cover every corner and they go around in circles. And if you can find the corner in that circle, then you're successful. Now that's physics.